we're going to basically start at the broadest area and narrow down as we go. So I'll start by talking a little bit about what computing science is in general, what sort of careers you can get in the area of computing science when you're appropriately trained, how you can get into that at UTS, and then how to get into UTS, essentially. Following that, one of our students will tell you a little bit about her experience here. Leading out, UTS has a number of IT courses. So we're in the Faculty of Engineering and IT. I'm in the School of Computer Science, of course. And our school is the #1 in Australia in computing science and engineering. And it's been ranked that for a couple of years now, so we're doing quite well. We have at least 6 degrees that relate to IT in general. So we have our sort of general all-rounder degree, the Bachelor of Science in Information Technology, where you can kind of construct your own degree to some extent and do anything. We have a Bachelor of Information Systems, which focuses specifically on information systems, of course, as the name suggests. Bachelor of Science in Games Development, same idea, but focusing on games development. Bachelor of Engineering, Software Engineering, where you learn about engineering skills and processes applied to software engineering. We also have the Bachelor of Information Technology Cooperative Scholarship, which is a very focused degree. And the one we came here tonight in blue there, the Bachelor of Computing Science Honours. So the Bachelor of Computing Science Honours focuses on the real core fundamental theory of computing science that supports all of these other degrees. So what is computing science? So it's a incredibly modern, vital area of research and study and practice. It informs how all these things that we're sitting here watching this presentation on work. It involves a reasonable amount of maths and science. You know, it's about how these things work in a scientific and mathematical way. And computing scientists are the ones who figure out how to solve new problems using these things, these computers. So the one you're sitting in front of, the phone that's in your pocket, the computer that's in your car that runs the internet, everything. So computing scientists are the ones who build the initial stuff to make those things work. To give some practical examples of that, some of these are general, some of them are relatively specific to UTS. You interact with the products of computing science every day, essentially. So things like Google Maps is a product of computing science. It involves a whole range of different things, from pathfinding to representations to global navigation, things like that. Twitter is a huge example of how to make computer science work. So not so much in the tweets itself, but how do you make the infrastructure of something like Twitter work? It is a massive network with millions of users sending data by the second. So much data passes through that. Just making that thing run is a real interesting problem to begin with. It also extends into areas like bioinformatics. So how do we use computers to solve interesting problems in biology and medicine? How do we take this technology that's in front of us and do something good? The same thing with like social robotics. How do we merge hardware and software to make useful robotic tools to make our lives better? And in the bottom right corner there is one that's particular, a project that is ongoing here at UTS. One of the lecturers in the School of Computer Science is running it. And it's a shark detection drone. So it involves a drone that flies out over the ocean near the shore, and using artificial intelligence and image recognition software, it looks for sharks. Right? So it saves running helicopters to do it. It's much more reliable than someone sitting on the shore attempting to do it, who can only see the top of the water, like the very top of the water. And it's a real practical life-saving application of the kind of things that we study. So as you can guess from those application areas, computing science also leads to a wide range of different possible careers. So we can go from anything like a data scientist to someone who's an expert in artificial intelligence, a software designer or developer, hardcore computing science research, areas like cybersecurity, quantum computing, and many, many others. Sort of essentially anything where you're building something new with a computer is an area that needs computer scientists to work on it. So this is just a small selection of some of the more popular ones. There's many others. So it does include things like robotics, fintech, applied computing, mathematical computing, all sorts of stuff. So how does the Bachelor of Computing Science Honours play into that? So the Bachelor of Computing Science Honours is a specially designed degree aiming at building capability in our students in those fundamental core areas of computing science to allow them to go into either research or industry at a higher level than just a general IT degree. So, of course, it teaches you all the basics of programming, how networks work, how to do software development, stuff like that. But it also teaches you how to approach new problems, how to look at new things, study them from a computational perspective, how to understand the maths that underpins all these things, and how to apply that to solve important, interesting, and difficult problems in computing. So this degree has been designed not just by some people sitting around in an office here, but it's been designed in collaboration with industry, researchers, both at UTS and external to UTS, and other advisory committees and boards to give a degree that actually both represents the broad range of skills that you need in a modern IT career, but also the depth of skill and knowledge that you need to really shine in quite high-end programming, IT, computing science, artificial intelligence, data analytics kind of career. So, of course, everyone says that about their degrees. So how is this degree different to other ones that you may be considering, particularly in Australia? So, as I said, it's a degree that prepares our students to work in highly technical roles. So we give you both a broad range of skills and a depth of knowledge, particularly in the major that you pick. Its focus is on the underpinnings of computing science, so less so on, say, information systems, for which we have a specific degree, or other applied areas of computing science, and more on understanding the underlying mathematical reasons for why things actually work on computers. I've just said maths a couple of times. Don't get too scared. I'll talk about that in a moment. It also tries to focus on what's coming up in terms of technology. So it's not that we ignore the things that are around at the moment, but by the time you get to the end of the degree, you will have engaged with cutting edge research in particular areas in computing science that you get to choose from. The last point, however, is what I think really differentiates this degree from essentially any other degree I can think of in Australia. It has an embedded research preparation stream. So that's why it's a Bachelor of Computing Science Honours. So honours is part of the degree. There's no sort of special extra year. It is part of the degree as you do it. And we have a stream, which you'll see a little bit of later, of preparation subjects which build up to allow you to engage in genuine research by the time you get to the end of the degree. So you might say, well, okay, I'm not that interested in research, but the skills you learn in doing that are really important for highly technical roles in computing science in industry as well. So it's not just aiming at academic research, it's aiming at those skills that you need to approach new problems, understand them, and build solutions to them. And that's really what research is. It's not just sitting in a room with some books behind you, thinking about something. It is building new stuff. And that's what we're really interested in. So what does that look like? So it's a 4-year degree because it has the embedded honours program. So this is a typical pattern of study. There is some flexibility in this, but most students do something roughly like this. So in your first year, you do some maths to help you understand what we're going to be talking about in the rest of it. That maths does not require any incoming knowledge. So if you didn't do maths in your HSC, or it's been a while since you've done it, don't panic. We teach you everything you need to know. You don't have to be especially mathematical to do it. This is not a maths degree, but you will learn some. Then throughout the degree, there's a variety of what we call core subjects. So these are the ones that feed into all the other stuff. So programming subjects, software development, database fundamentals, networking fundamentals, things like that. You will pick a major. So that's the stuff in the blue there. So I'll talk about the available ones in a moment. But these are the areas of specialization. So you do 8 subjects in a particular area. So between the sort of the red and some of the light gray, you get your breadth of IT specialization, computing science specialization, And then in the blue, you get depth. In the very dark gray there, you have electives. So you can use those for essentially whatever you want. Technically not in the handbook yet, but you can do sub-majors. So if you want to add an extra specialization, you can. So that's upcoming. Or you can do other things like languages. So you can augment your degree with other things. Now, the other part that I particularly want to talk about is the two light gray bits at the bottom in second year session 3, third year session 5, and the dark gray bits at the top at the end there. Those are your honours and research preparation streams. So right almost from the beginning of the degree, so we give you a year to get some fundamental skills down, but starting from second year, we start to involve you in research. It starts off fairly gentle, but you are learning how to become a competent researcher right from the beginning. So from those studios into the honours project, you get to learn research skills. You also get to engage with researchers at the university and sometimes industry if there's available projects. So this teaches you, like I said, to not just apply technology in known existing ways, but to do new things, to build new interesting software that solves new interesting problems. And that's through the degree. So you're not left right at the end. So back in my day, when I did my undergraduate, what you did was a 3-year undergraduate degree, where you did some subjects. And then if you did pretty well, they tapped you on the shoulder at the end of the third year and said, hey, you got good marks. Do you want to come and do honours? And, oh, yeah, that sounds exciting. And then you turn up and they say, okay, here's a research project. Off you go. Spend a year doing that. And you had essentially no idea what you were doing. We don't do that here. We prepare you from the start. So by the time you get to your honours project, you've already done 2 other research-related subjects. So you have the potential in your honours project to do something genuinely new, which is not that usual in degrees, particularly in Australia. The other thing that does is allow you to engage with potentially different research areas throughout the degree. So for your first studio, maybe you're interested in AI, you go and work with someone in that. For the second one, maybe you're interested in interaction design or quantum computing, you go and do something on that. So by the time you get to your honours project, you at least have some idea what the things to pick from are. So again, when I did it, you kind of had to hope that you knew one of the academics and you kind of liked what they did, but it was a bit of a grab bag. With our structure, you know what you're getting into. And if you get lucky, you can work with the same people through the studios all the way through your honours project. So you can build a real relationship there. Okay, as I said, you'll pick a major, which gives you your area of specialisation. And our computing science degree has quite a range of different specializations. So it covers a variety of normal IT specializations, so enterprise systems development, information systems management, interaction design, to some other technical areas which are becoming more popular, like cybersecurity. So we've got 2 different cybersecurity majors which focus on different areas. We've got some mathematical majors. So you can, if you're on the really mathsy side, there's the opportunity to take computing in that direction. So stats, operations research, mathematical analysis, which to some of you may sound very dry, but there are some really interesting opportunities in that. And we also have one of the few undergraduate degrees that does something in quantum computing. So we have an outstanding quantum computing research group here, and that's something that I think is exciting and a bit different here at UTS. Okay, so now Kashish is a student here in the Bachelor of Computing Science, and she's going to talk to you a bit about her experience with the degree.
Thanks, Luke. Hi, everyone. So my name is Kashish, and I study a Bachelor's of Computing Science honours. I'm currently in my 3rd year, majoring in data analytics and artificial intelligence. So basically, a little bit about my insights. I started this degree right when COVID happened. So it was a little bit hard because we switched completely online, but I must say that I've really enjoyed my degree over the past 3 years. I came with a very limited programming experience, and I was really scared that I wouldn't be able to cope with the subjects and everything. But the really good thing is that all of the subjects at UTS have been designed that you are able to pick it up as you go along. So I did do a lot of core programming subjects. I'm currently doing one, which is data structures and algorithms, which is core C++. And because I didn't have any C++ knowledge, the subject actually provided with the first couple of weeks was just learning the language and then actually having a chance to code with it. So So like it's been like a really great thing. And also, if you feel like no one's going to help you, just ask. Like that's what I did. I just went to my tutorials and I just asked my subject coordinator, or I just asked my tutors to help me, and they really will help you. Like that's what they're for. Also, I'm like, I guess like the degree is designed in a really nice way because you have a chance to code in all of the different languages. So far I've worked with Java, Python, C++. I've worked with HTML, CSS. So I've had a chance to work across all of these different languages and gain all of these skills and things like that. I'm currently doing my second studio for computer science, and I'm having a chance to work with social networks. Whereas for the first one, I worked with big data and AI, and it's really cool and interesting, and I've got a really good group. So far this degree has been really good. There have been a lot of challenges because sometimes it can become a little bit hard, but you do get a lot of help. Like I've had amazing subject coordinators, really good teaching staff that have helped me a lot along the way, and also all my friends and my peers, they've also helped me. And we've got like UPass and things like that will also help you. So that's some of my insights about UTS. I've also gotten a really great role through this degree as well, which is also allowing me to actually like apply all of these theoretical concepts into practical, and it's been really helpful. But I wouldn't say that the degree is like really easy. It does have its challenges. Like there are times where you will struggle, but always ask for help and you will always get help. That's the best part about this degree. But I'll pass it back to Ash. Thank you so much.
Thank you, Kashish, for giving your summary. Now we'll move on a little bit to more of the admin side of the session. So talking about ATAS and adjustment points for the UAC rounds. So for uni, what you get is a selection rank when you get chosen for your subject. So those are your points that are added to your raw ATAR. So here at UTS, adjustment points are capped at 13, and adjustment points can be given for a number of factors. So this includes completing the UTS engineering and IT questionnaire, getting good results in relevant HSC subjects, your gender and special circumstances, and more. So highly recommend you checking out our website to explore these factors. Now moving on to the UAC Key Dates. So just as a timeline overview, so between April and June is when the scholarship applications. So it's a really good chance for you to see what's there on offer. And then August 27th is our open day. I recommend you come to our open day. It's your opportunity to come see the campus in person, as well as to talk to the lecturers as well as student representatives to see what courses interest you. In September is when normally scholarships close as well. So for exact dates, I'd highly recommend visiting our website because these haven't fully been finalized as of yet. And then after your HSC exams, which is in that October-November period, your ATARs get released in December. And then from December to March, there's actually multiple UAC rounds where you can receive multiple offers through UAC. This is where you can change your preferences for each round and receive different offers. So it's really important to utilize those chances to really get the degree that you're interested in. A little bit about UTS early entry as well. So UTS, starting last year, have started to offer an early entry program. So this is your opportunity to receive an offer to study at UTS before you sit your final exams. Eligibilities for current domestic or international onshore Year 12 students, and applying through this is applying through the UTS online application portal. So this is different to UAC. It is free to apply and the applications are open around June and July. The exact dates have yet to be confirmed, so keep your eyes peeled for the website and you'll get your offer prior to the HSC. In terms of student support, so in UTS, there are currently no prerequisites to our degrees. However, there's recommended knowledge, and if you haven't completed those subjects in high school, do not fret. There are many ways to obtain that knowledge here at UTS. So there are currently bridging courses offered in maths, physics and chemistry, as well as UPass sessions. So that stands for Peer Assisted Study Success. And it's a program where students in the year above who've already completed the subject come and mentor the students who are currently completing, and they've achieved really high marks. And it's a really good program to gain support. All right, and then to connect with us digitally. So here is just the context for the Faculty of Engineering and IT. So connecting on our socials, emails. This is especially an important area. If you think of questions and you weren't able to get them answered in this session, you can always send us an email, as well as checking out our website.